Hi students, this is Mr. Yao. Today we are going to continue to learn more about triangle congruence. And last time we have learned side, 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 and side, angle, side. Today we are going to learn ASA, angle, side, angle, and AAS, angle, angle, side. But first, let's review what we have learned last time, some prior knowledge. For question A, triangle PQS. And we want to actually show it's congruent to the other shape. So first we can notice there's a single bar right here. These two sides are actually congruent. And we also have the angle that are congruent. And something that we have learned last time, if the two shapes share a side, that side is clearly going to be a pair of congruent sides for both figures. And in this case, it actually works. Side, this is the included angle, and side. So justification will be side, angle, side. And again, I emphasize again, this angle has to be the included angle, which means the angle needs to be between the two sides. And now we can write the statement PQS. That's clearly the side in the middle, so it's got to be PQT for the other triangle. Question B, what other information is needed for side, side, side congruency? Two bars indicating these two are the same, and we also have one side that's shared, so clearly the only piece of information we need would be the third pair of sides. So you can see FE and FQ are the corresponding, FG are just a shared side, and in this case, we can write EG is congruent to QG, or you can write the other way, GE is congruent to GQ. That's question B. Now let's move on to today's lesson. ASA, triangle congruence theorem, if two angles and the included side. So this time, something to emphasize on is included side, which means the side has to be between the two angles. So two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. You can see this clearly indicates B and E are the same, A and D are the same, they're congruent. Then the side in the middle between A and B is right here. That side has to be the same as DE to actually use ASA. Next, with two angles on one side, that's not the only option. We can actually have AAS. This works as well. If two angles and a non-included, so see this time, if it is not included, and if this is the included side, then we have either this one or that one to be the non-included. So two angles and one non-included side of one triangle are congruent to two angles and a non-included side of another triangle. The triangles are congruent. So you can see with angle and a side, we do have two different options. So now let's clarify a bit more. Why is the angle side theorem true? Here's the reason. If you know two angles inside a triangle, how could you find a third angle? We have already learned last time, we have reviewed in the previous lesson about triangle sum theorem, so we can use 180 to subtract the two angles. Then we would be able to find the third angle. So basically that means if we have a pair of angle, let me change the color. If we have this first pair of angle, and we also have the second pair of angle, we basically also have a third pair of angle. So it could potentially be angle, 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 side, angle. There's this extra piece of information, which basically means if you have angle, angle, side, you will automatically have right here, angle, side, angle, due to triangle sum theorem. Because as soon as you know two angles, you will know the third angle. That's why this will for sure still work. So angle, angle, side, and angle, side, angle, they both work. Now let's have a look at some examples. Same idea as last lesson. We are going to need to state whether is SSS, I mean not SSX actually, but whether is ASA or AAS. Congruent theorem is used to justify. If there's not enough information, we need to make a statement. We need to write NA. So first, this one, triangle DEC. Clearly, C is the last point right there, and we see they're 90 degrees. Perfect, that's like the angle. And we see the side, perfect, that's one side. And something if you remember, if two angles are vertical angles. Again, they are called vertical angles. Vertical angles are actually congruent. So we do have angle, side, and another angle because this side is actually the included. So angle, side, angle works in this case. The only thing we need to be careful is when we write the statement. DEC. It starts with a 90-degree angle that corresponds with A, and then is actually going to the other point, not the one that they share. So it's got to be A, B, and then C. That is example 1. Next, example 2. Statement BEC. We're trying to compare with the other triangle. Let's have a look at the information that we have first. So again, with these given information, well, we have at least a side and a vertical angle again. So we have the angle. And lastly, parallel lines. If you remember, last time when we talked about parallel lines, we can actually have this kind of shape, which is, let's see, right here. That's a Z shape. These two angles could actually be alternate interior angles, and they are the same. And in this case, we would have another angle, and you can see the side is not included. So in this case, we can call that angle, angle, side. We just read it in order, angle, angle, side. And now we can write the statement BEC. You see, this time we actually start from the shared point. So it's got to be B for the other one as well. BEC. It's going to the angle that we just labeled. So it's going to be BAD for the other triangle. Now that's not quite the only way. There's also a special thing about this question. If these two sides are parallel, we can also form our kind of Z shape like this. Then we could potentially have another pair of angles right there. And that would actually give us the angle, side, angle. So it could be angle, angle, side, or angle, side, angle for this question. That is example 2. Next, example 3. GFH. We can clearly see they share this GH side. That's at least a side. And then we can see they have this angle that are the same, but besides that, there's nothing else that's actually being labeled. There's no parallel line. There's no line being marked that they are congruent. So we only have the angle and the side. The angle and the side. That actually does not work. So not enough information. We will write NA for example 3. Next, example 4. Let's see, this time we have one pair of angle. Great, good start. And we also have this shared line right here. So we at least have the angle, we have the side, perfect. Lastly, if you know, when we have a straight line, that's basically 180 degrees. So if this is 90 degree, that's also guaranteed to be 90 degrees. And these two angles actually will be the same. So that means we do have another angle, and the side is actually in the middle between the angles is included. That is actually going to be angle, side, angle. Now let's write the statement. XWZ, start from the point further away from the shared line. So that means it's got to be a Y, and then WZ is being shared without even rotating or anything. So that's the statement. And that is example 4. Next, example 5. ASA. If it's requiring for ASA, we know at least one pair of angle. Great. So that's a good start. And we have another pair of angle. Great. So we gotta look for, so angle and angle are set. We gotta look for the side, and the side needs to be the included one. So it needs to be these two. AB is congruent to DE. That's the statement. That's the extra piece of information that we need. Next, example 6. AAS. So we have, let's see what we have. We have angle right here. Great, good start. And we have a side right here. Okay, and that's the side actually right here. But the question said angle, angle, side. So again, this angle indicates is the the side actually. This if it's AAS is actually indicating that is the non-included side, which means we can't use this angle. We can't. because that would give us angle, side, angle. We would have to use the other angle right here. So angle, side, we can't use that one. It's got to be this one because that's the actual piece of information that's required. So angle A is congruent to angle D. It's not saying that you can't use ASA. Just for this question, the requirement says we are trying to use AAS to prove. That's why you need the angle to be the one that is not including the side. Okay, next, example 7. ASA. Don't forget vertical angle, automatically we have the A, perfect. And then S, that's the side that's being shared. I mean, not shared, that's the side that is the same. And now we need the angle to actually make sure the side is included. That would be right here, these two angles. So angle R is congruent to angle B. That is example 7. Let's move on to the last bit of the lesson. So we've covered pretty much all the combinations for the S and A. AAA can be used to show triangle similarity. So again, we have covered so far side, side, side. We have covered side, angle, side, angle, side, angle, 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 side. And this can be used for similarity. So we just have side, side, angle. That actually does not work. And here's something that may help you to remember. Don't say it, just think about it. If you put these 3 letters backwards, that's going to give you a word. And typically, that's not a word we should say during class. So, that's why it doesn't work. Given 2 sides and non-included angle, which is side, side angle, that's actually not enough information to prove congruence. And here's the reason why. You see, I have this angle that's being shared, and I can actually form another side that's the same as this angle. So these 2 triangles have this shared angle, that's the angle, and they have the shared side, which is the B, so we do have the side, and there's another side, which is the A, and clearly you can see this triangle CAB and this other triangle CAB, they are not congruent at all. These are 2 completely different triangles. So that's the reason why. And here are 2 links. If you would want to see a deeper, more detailed explanation, you can try to look for these. Otherwise, just remember, you can't say that word in class. That's why it just doesn't work. Now that covers everything about triangle congruence. And that's the end for this lesson. Thank you.